Ever wondered how Python handles different types of data? In the vast realm of Python, understanding the various data types is akin to mastering the alphabet before writing a novel. It's the fundamental building block that allows you to construct complex programs with ease. Python recognizes a variety of data types, each with its own unique properties and uses. These include numeric types like integers and floating point numbers, sequence types such as lists and strings, mapping types like dictionaries, set types, and the Boolean type. Just like how we use different tools for different tasks in our daily lives, Python uses these data types to perform various operations in a program. Whether we're counting the number of apples in a basket or storing a list of our favorite songs, Python's data types have got us covered. So, ready to delve deeper into this fascinating world of Python data types? Stay tuned to learn more about each Python data type. Firstly, we dive into numeric data types. These are data types that hold numeric values. Python is quite flexible when it comes to numbers, and it provides 3 numeric data types: integers, floating point numbers, and complex numbers. Let's start with integers. In Python, an integer is a whole number, positive or negative, without decimals of unlimited length. For instance, the number 7 is an integer, so is negative 42. Even the number 0 is an integer. In Python, you would represent these as 7, negative 42, and 0. Next, we have floating point numbers, or floats. These are real numbers with a decimal point dividing the integer and fractional parts. A floating point number can be as simple as 0.1 or as complex as 3.14159. In Python, you would represent these as 0.1 and 3.14159. Last but not least, we have complex numbers. In mathematics, a complex number is a number that can be expressed in the form a plus by, where a and b are real numbers and I represents the imaginary unit. For example, 3 plus 4i is a complex number. In Python, you would represent this as 3 plus 4j, where j is the Python equivalent of the imaginary unit e. Now you might be wondering why Python has 3 different numeric data types. The answer is simple. Different numeric data types are used for different purposes. Integers are great for counting or ordering items. Floating point numbers are ideal for representing real numbers, and complex numbers are used in fields like engineering and science, where they're indispensable for representing and solving certain types of problems. Now you understand how Python handles numeric data types. Remember, whether you're dealing with integers, floating point numbers, or complex numbers, Python has got you covered. Next on the list, we have sequence data types. Diving into the world of Python, you'll often encounter situations where you need to store multiple items in an organized manner. That's where sequence data types come into play. First up, we have the list data type. Lists are like the jack-of-all-trades in Python's data type toolbox. They are mutable, meaning you can change their content without changing their identity. You can have a list of numbers, a list of strings, or a mixed list of integers, floats, strings, and even other lists. For instance, my underscore list =1 apple 3.14. You see, it's pretty flexible. Next, let's look at tuples. A tuple is similar to a list in that it can store multiple items. But here's the twist. Tuples are immutable. Once you create a tuple, you cannot change its content. It's like a list, but with a read-only status. An example could be my underscore tuple =1 apple 3.14. Notice the rounded brackets. That's a tuple for you. Finally, we have the range data type. Range is a rather unique sequence type, used predominantly for looping a specific number of times in for loops. It's not as versatile as list or tuple, but it has its specific use cases. You create a range by using the range function. An example of a range is my underscore range =range 110. This will give you a sequence of numbers from 1 to 9. In this scene, we've explored the 3 sequence types in Python: the flexible list, the immutable tuple, and the specific use case range. Each has its unique characteristics and use cases. Remember, the key to mastering Python, or any programming language, is understanding when and how to use its different tools. That covers the sequence data types in Python. Moving on, let's explore the mapping data type. In Python, the primary example of a mapping data type is a dictionary, often referred to as dict. A dictionary is a mutable or changeable data type that stores mappings of unique keys to values. Here's a way to picture it. Imagine you're at a library. Each book has a unique identification number, and that number leads you to the specific book you're looking for. That's how a dictionary works in Python. The unique identification number is the key, and the book is the value. Let's look at an example. Suppose we have a dictionary called mydict, and it's defined as mydict = name, Alice, age, 25. Here, name and age are keys, and Alice and 25 are their corresponding values. We can retrieve the value of age by calling mydict, and that's how Python uses mapping data types. Now, on to set data types. In Python, a set is a collection that is both unordered and unindexed. It's pretty much like a bag of unique items where the order doesn't matter, and you can't have duplicates. For example, you could have a set of your favorite fruits like this: apple, banana, cherry. Notice how there are no duplicate items here? That's the beauty of sets. Then we have frozen sets. They are just like sets, but with a twist. They are immutable, which means once a frozen set is created, you can't change its items. It's like a set, but with a no takebacks policy. An example of a frozen set would be frozen set. So, whether you need a mutable collection of unique items or an immutable one, Python has got you covered with set and frozen set data types. And with that, we've covered set data types. Next, we will discuss the Boolean data type. In the realm of Python, Boolean is a simple data type with two possible values, true or false. It's like a switch. It's either on, which is true, or off, which is false. Boolean values are primarily used in conditional statements, which we use to make decisions in our code. Let's consider an example. Suppose we have a variable, is Python fun, set to true. Now, if we were to use this in a condition like an if statement, it would look something like if IcePython fun print Python is fun. Here, the message Python is fun would print because our Boolean variable is Python fun is true. If it were false, nothing would print. Boolean data types are straightforward, yet they are a powerful tool in programming. They allow us to control the flow of our programs and make decisions. That covers the Boolean data type in Python. Finally, let's recap what we've learned about Python data types. These are the building blocks of Python programming, each with its own unique characteristics and uses. We started off with numeric data types, which include integers, floating point numbers, and complex numbers. Remember, integers are whole numbers with no decimal point, float numbers can have a decimal point, and complex numbers are represented in the form of a plus ba, where a and b are floats. Next, we dove into sequence data types, which encompass lists, tuples, and strings. Lists are mutable, meaning they can be changed and are enclosed in square brackets. Tuples, on the other hand, are immutable, meaning they can't be changed once defined and are enclosed in parentheses. Strings are a sequence of characters enclosed in either single or double quotes. Then we explored the mapping data type, represented by dictionaries. Dictionaries are mutable, unordered, indexed collections of key-value pairs, enclosed in curly braces. The key is unique and acts as an identifier for the value it represents. Moving on, we discussed set data types. Sets are mutable and unordered collections of unique elements enclosed in curly braces. They're fantastic for removing duplicate values and performing mathematical set operations. Our journey led us to the Boolean data type. Booleans represent one of two values, true or false. They're typically used in conditional and comparison expressions to determine the flow of a Python program. In a nutshell, understanding these data types and how they interact is crucial to becoming proficient in Python. Each type has its own properties and functions, and knowing when to use each one can greatly enhance the efficiency and readability of your code. Understanding these data types will help you become a more effective Python programmer. Thanks for watching. Thanks for